Okay, welcome back. So now I'm going to talk about how to calibrate the neighbourhood. So the neighbourhood is really at the core of the model. So let's just bring the switchboard back in. If you remember, if we've crashed out of it, we can load that stuff in from the settings using that script there. The switch model setup will bring in our raster maps and our we can load project actors, our data, or anything else that we want to store as we go along. Those are stored as we complete a model block. They're stored automatically. So we're now at the stage. We're at stage number 4. We're going to calibrate our neighbourhood. So the essential principle behind the neighbourhood effect is that in the cellular automata model, we model land use change basically as a series of states of attraction, right, or repulsion of one land use to another or to itself in a different time step. Okay, and we do that by applying a focal filter or a moving window of values to each land use. To specify how attractive it is over what distance away from that. So our focal filter basically creates a distance decay effect, which we then use an attractiveness to control where land use will go in the next time step. So I've added this here to the workspace, the main Apollo directory, this file here, which is called neighbourhood influence calculator. Okay, just so you can see a little bit how this works. So the first thing to note is that the weight is just that. It's a weight. It's a completely arbitrary number which controls the influence of one land use on another, or one land use on itself in the next time step. So we have the influence of urban on urban. What this means is that currently we have a map of urban land use in the year 2000. This means that when we run the model forward in yearly time steps, land use in 2001 will want to know where to go. We're going to tell it where to go on the basis of its relationship with urban land that was already there before, or urban land that already exists, and on the basis of other land around which it needs to be attracted to in order to grow. Okay, the most important thing about this, the most important thing in the model will not work unless you set, you remember we have active uses, passive uses, active uses, static uses. You must set the land use to itself for each of your active land uses. Okay, otherwise the model will not work. And we can remind ourselves what they are by looking at tableau 1. AAA, so herb, solar, wind. So this model will run perfectly as long as we set up a neighbourhood rule for herb, solar, solar, wind, wind. Okay, if we do nothing apart from that, the model will work perfectly well. It will just simply allocate the land use on the basis of that very simple rule. Okay, herb will be attracted to herb, solar will be attracted to solar, wind will be attracted to wind, right? So that means that instead of getting a blank map, it'll go back to where it was at the beginning. It's not quite as straightforward as that, because we want it to go back exactly where it was in the previous map, and that means we need to set a rule at land use 0. That is on top. That's urban exactly where urban land use was before. Okay, a cell of urban in the new map is going to go back to a cell of urban in the old map, right on top of it. So that needs to be the strongest rule in the model. Notice these are distances. My cell sizes are 200. It's a 200 resolution maps. This is 200 meters, 400 meters, 600 meters. This is 1 cell away from urban land, 2 cells away from urban land, 3 cells away from urban land, 4 cells, 5 cells, etc. So what I could do, okay, is I could say 1000. I type 1000 here, values in red, answer in blue. Okay, so look what happens. So what's going to happen? So what I've now said is that urban land wants to be preferably, that's the highest value, it wants to be 200 meters away from where urban land was before. So when I apply this filter and I then run the model and assign urban land, what's going to happen is all the urban land that existed is going to migrate outwards to 200 meters away, because that's the strongest rule. Now this is not a distance decay effect, this is a distance increase effect. We're basically saying here that urban land gets more probable to be allocated at 200 meters away from existing urban land. Well, that's ridiculous. We don't want to do that at all. For example, we can change it back to the way it was before. So this means that the strongest influence for urban land to urban land is exactly where urban land was before. Yeah, which makes sense, right? However, we don't want urban land just to go back to where it was before and nothing else. We want it to grow outwards from the centre. So we also need to make it attractive at a distance away at 200 meters. As I've said before, if we make it more attractive than at 0 meters, then all the land use at 0 meters is going to migrate to 200 meters away. We don't want to do that either. In general, the best and the simplest rule is to try to follow quite a steep curve. In general, at city's edges, there's quite a steep drop-off. If you have a very shallow curve here, what you'll get is a kind of fungus effect where the urban areas will just grow in a kind of like a fuzzy spread outwards. We won't get this sharp cutoff, which is so typical of urban development in real life. So we probably need to adjust this. So what we could do, for example, is we could just choose 1000, and we could take this down by, say, a factor of 10. That's always a good start point at 200 meters away, by a factor of 10. And then we can say bring it down a little bit more. It's still attractive. It's still, urban land still wants to be 400 meters away from existing urban land, but not nearly as much as it wants to be where it was before. And then we can bring that down maybe to 10. Okay, and then we can bring that down maybe, well, we could perhaps try 2, and then we could try 1, and then all the rest of these are going to be 0. Okay, right. So what we've got there is we've got the weight at 0 distance is the strongest. Urban land in the next time step wants to be, most of the time, more than anything else, wants to be where it was before. After that, the next most exciting place for it to be, the next most attractive place, is in the next cell, 200 meters, right next to it. After that, a bit less attractive, but still attractive, it wants to be 400 meters. After that, it wants to be 600 meters, and so on, gradually declining down to 0. So what we've got here is we've got, these are our rules: 0, 200, 400, 600, 800, and then by the time we get to a kilometre away, it's only 1, and then over a kilometre away, it's down to 0. So that's a simple neighbourhood rule for urban on urban. This kind of rule is absolutely perfect standard rule for the attractiveness of any land use to itself. Okay, so now we're going to go back into the model and we're going to apply that rule and see how we apply that in the model. Okay, so we're going to go back. I'm going to go to calibrate neighbourhood. So what's happening here? Okay, so if we'd loaded the sim01 R data file, the predefined pre-calibrated model, we would already have some neighbourhood matrices in here. We don't. We're going to have to create them. We can just check that. It will say can't proceed. Okay, so you need to create them. Okay. So we'll just go back again, and we'll create some by hand. Okay, we could import them. I should point out that actually we already have some. neighbourhood. So these are the ones we made earlier, in a sense. And notice we've just got the minimum. So if you loaded up sim01, you would be able to run the model. You'd have all these stored in the sim01 workspace, and here they are outside. In case you lose them, you can just load them back in again with the I to import matrices. So that's what that will do if we import them, right? But we're not actually going to do that. We're going to create them from scratch. Okay. So important thing to remember: if you're happy with these rules and you want to fiddle around creating them from scratch or creating new rules, remember to save your old rules. Okay, important. So you could pick these up, you could copy them, and you could put them, for example, in settings original copy or something like that. Okay, because these always get overwritten as you work. I should say, as you change neighbourhoods, as I say, they get overwritten, but you have this useful document map files. Okay, and this is a running document, okay, of modifications. Okay, it appends. Okay, so here you see a whole series of modifications made to these rules. Okay, so as we modify these rules, they're going to be added into this document mapfiles.csv. Because we're creating our rules from scratch, we're not bothered about that at all, and actually we can just delete it. Okay, I'm going to create them from scratch. All right, but that's how that works. As you modify them, it gets added to the running list. Okay, so what do we mean by creation and modification of neighbourhood rules? So we want to go to create, see, there we go, and the first thing it does is it just creates a whole load of blank matrices so that we can input the rules. So it's created a matrix, a neighbourhood rule matrix for every land use to every other land use. Now remember what I said, that we've got 3 active land uses. We've got herb, solar, we've got wind. So to run this model, the minimum we need to do is we need to create herb to herb, solar to solar, wind to wind, right? Everything else is extra and optional. Okay, so let's start by creating herb to herb. So that's the one that we looked at in the spreadsheet. And look, we can see mat herb, that's matrix number 33. Okay, there we go. As expected, it's absolutely blank. Of course, we don't want to leave it blank, we want to edit it. Let's edit that. Again, that's going to bring up our neighbourhood size and influence table. So going back to this helpful handy spreadsheet, we decided we'd have a weight of 1000, but right on top of the cell itself. Okay, and then there's going to be at a distance of 100 away, distance of 400 away, 600 away, 800 away, 1000 away, etc. It's progressively declining down to 0. Okay, so how we put this in, right? Okay, so there's a little bit of a trick here, which is maybe not all that easy and perhaps should be changed, but I'll point it out here so we don't get tripped up by this. So then when it's talking about the neighbourhood size, okay, this is the size to the left of the central cell. It does not include the central cell itself. So our neighbourhood size is 1, 2, 3, 4, 5, 6. No, so we've got nothing here, so it's 1, 2, 3, 4, 5. Okay, very important. Does not include the central cell. So our neighbourhood size is 5. When we come to the influence values, we actually need this central cell to calculate it. So we're going to have to put that in too. So remember, you're going to have the central cell, which is 1000. And after that, remember, we got the neighbourhood size is 5. So we need 5 more values after the central cell. We just separate them with commas. 10, 2, 1. And then we submit. Okay. And then hopefully he'll be happy about that. Yeah, okay. So it's done a series of things, it's finished, and it's created an 11 times 11 matrix with those rules. It's gone straight back to the selection panel. Okay, so this is finished and this is fine, but we might be interested in reviewing it. So if we want to review it, we just go straight back to number 33. Okay, and there we are, right? And that's calculated that. It's calculated the distance decay effect based on Pythagoras' theorem. So it decays with distance. The distance decay, the diagonals are longer, so the distance decay effect is greater at the corner cells. So that's what that's doing there. Okay, and now we're going to create two more, solar and wind. Okay, so let's edit them. We don't want to edit that. We're not going to edit that particular one, so let's return to the list. Solar, wherever that is, there, 25. Okay, so let's edit that one. Okay, same thing. Well, we haven't done anything special for solar, so let's just, we haven't used the table, so let's just do this on the fly. We could have again a 5-cell neighbourhood. We could make it say, yeah, we could do, in fact, do just put in the same rule, 100, 20, 10 to 1. Is that right? 1, 2, 3, 4, 5. Yeah. And look what you can do if you're going to create the same rule. You can just Control C to copy. Okay, so there we are. 5. Submit. Okay, so that's solar with 25. We'll look at that again. Yep. So that's done the thing. We're going to return to the list. We're going to create wind, which is down here somewhere. No, water wind. Where's wind? 49 is wind. Okay. I'm going to edit that. That's a 5-cell neighbourhood. We're going to submit that. Okay. And then we're just going to go to wind again. We're going to have a look at it. 49. Yes, that's done fine. Okay, so now we're going to exit. Okay, it's going to tell us exiting now. Right. So now what this does is it's going to save our neighbourhood settings, because obviously they're very important. Now, the neighbourhood block, at this point in time, we don't create or modify any maps in the neighbourhood block. We do that using the neighbourhood map matrices at model runtime. Okay, so you don't need to worry about importing all the layers again if you crash out at this stage, because, or if you just close down and you've had enough, you come back another day, because this is all stored in the calibrated neighbourhood block. Still thinking about it, still saving. Okay, so once it's done, we will see it hopefully in here. Project neighbourhood. Okay. Oh, in fact, yeah, no, it wasn't storing that. What it was doing is it was writing to the map files. As I said before, I don't think we've created the neighbourhood. Ah, okay, so this is a good opportunity. We haven't actually saved that image, so let's save the image to make sure that we store this. And we're going to call it project nhood.rdata. Okay, so that we make sure that what we just worked on actually gets properly saved. So what the model was actually doing there, it was creating map files, remember, which we deleted, and storing our modifications, right? So as long as we don't delete map files, next time we modify them, that will be added to. Okay, so we've always got the latest, most up-to-date version of the neighbourhood rules in map file, right? So we can come back to it. Okay, so I think that's a good point to stop for now.